Good morning, guys. So today we will discuss function operations and composition. So first of all, I will be talking about operation on functions. So we have a given two functions, f and g. Then for all values of x for which both fx and gx are defined, the function f plus g, f minus g, fg, and f over g are defined as follows. So f plus gx is fx plus gx. So this is the sum, okay? So fx, gx, they are given function, okay? So they are given functions. So how do you define the sum? If you have f plus gx, so this is same as fx plus gx. So this is the sum function, sum of the functions, okay? So the difference is defined in the same way. If you have f minus gx, so this is same as fx minus gx. Okay? And multiplication or the product, this is fgx is same as fx times gx. And the division, or you can say the quotient, if you divide a function f by g, so f over gx is same as fx over gx, where gx is not equal to 0. Did you get it? Yes? So now, if you look here, this is difference, right? And this is product. And the last one is quotient. Okay? So if you want to find the domains, so the domains of f plus g, f minus g, and fg include all real numbers in the intersection of the domain of f and g. And the domain of f over g includes those real numbers in the intersection of the domain of f and g for which gx is not equal to 0. Okay? Are you with me? Yeah. So if you look so let's do this, okay? So your fx is x squared plus 1. And your gx is 3x plus 5. And we want to find out f plus g1. And look at the definition. If you have f plus gx, so this is same as fx plus gx, right? So f plus g1 will be same as f1 plus g1. You got it? So now what is f of 1? So how do you get f of 1? So what is your fx? X squared plus 1, right? So what will be the value of f of 1? What is f of 1? You plug in? So yes, that will be 2. So you plug in 1 here, so this is 1 is square plus 1, which is 1 plus 1 equal to what? 2. So f of 1 is 2 plus, so similarly, can you find g of 1? So g of 1, you plug in x equal to 1. So 3 times 1 is 3. 3 plus 5 what? 8. So now this is 2 plus 8, which is what? 10. Did you get it? It's simple, right? So similarly, how do you find f minus g of negative 3? So f minus g of negative 3. So the difference of functions is defined like this. F minus gx is same as fx minus gx. Is that right? So now it is going to be f of negative 3 minus g of negative 3. Does that make sense? So what is f of negative 3? What is f of negative 3, guys? So what is your f of x? X squared plus 1, right? So you want to evaluate f of negative 3. So you plug in x equal to negative 3. So this is negative 3 squared plus 1. Is that right? So this is going to be 9 plus 1. What is this? 10. So this is 10 minus, what is g of negative 3? So your g is defined as 3x plus 5, right? 3x plus 5. So what is g of negative 3? You plug in negative 3 here. So 3 times negative 3 plus 5. Make sense? So what is 3 times negative 3? What is 3 times negative 3? Negative 9 plus 5. So what is negative 9 plus 5? Negative 4. So g of negative 3 is negative 4. So you plug in negative 4 here, right? So now this is 10. Negative times negative is positive 4. So which is what? 14. So f minus g of negative 3 is 14. Did you get it? Good. So now, if you want to find fz5, okay? So let me if you want to find out f times z of 5, by definition, fzx, the product, is fx times gx. Is that right? So it will be f of 5 times g of 5. So now you need to find out the value of f of 5, okay? So your f of x is defined as what? X squared plus 1. So if you want to find f5, so it will be 5 squared plus 1. Is that good? Make sense, guys? So what is 5 squared? 25 plus 1, this is what? 26. So f5 is 26 times. Now your gx is 3x plus 5. So you want to find out g5, right? So you plug in 5 here, right? So 3 times 5 is 15. What is 15 plus 5? 20. Make sense? Right? So this is 20. So you multiply 26 and 20. I think that will give you 520. Did you get it? Yep. And the last one is you need to find out the f over g of 0. So this is f over g of 0. And remember, this f over gx is defined as what? Fx over gx. Right? So this is f0 over g0. So what is your f0? You plug in 0 here, okay? So what is your f0? So fx is x squared plus 1. You plug in x equal to 0. So this is 0 squared plus 1, which is what? 1, right? So this is 1 over g of 0. So your gx is 3x plus 5. So you plug in x equal to 0. So this is 3 times 0 plus 5. So that will give you g0 equal to what? 5. So this is 1 over 5. Make sense, guys? So now we got it, right? So look here. So you got to be careful here when you want to find the domain. Look here. So this is how we find the domain for the what? Sum, difference, product of the function. So for the function f and g, the domains of f plus g, f minus g, and fg include all real numbers in the intersection of the domains of f and z. Okay? So while the domain of f over z includes those real numbers in the intersection of the domains of f and z for which gx is not equal to 0. So you have to understand this. So the domain of f over z include those real numbers, okay, in the intersection of f and z, right, such that gx is not equal to 0. Because if gx is 0, it will be what? Undefined. Right? If you have a 0 in the denominator, so that will be what? Undefined. So now let's work here, okay, guys? So if you want to find the domain of these functions, okay, let's say you want to find the domain of fx and gx. I just want to calculate the domain, okay? I want to find the domain for fx and gx. Look here. So your fx is 8x minus 9, and your gx is radical 2x minus 1. So what is the domain of fx? What do you think? How do you find the domain of fx? So our goal is to find domain of f plus gx. We want to find this. Okay? So to find the domain of f plus gx, we need to find the domain of f and what? Domain of z. Right? And then we need to find the intersection of domain of f and domain of g. You remember that? Like the domain of f plus g, f minus g, and fz includes all real numbers in the intersection of the domain of f and domain of z. Does that make sense? So that's why we need to find the domain of f. So what is the domain of f? So for what values of x this function is defined? Is there any value of x that create a problem for this function? So remember, like a long time ago, we talked about the linear function, the function of the type fx equal to ax plus b. Remember, this is a linear function. Remember that? This is a linear function. And then in a linear function, if a is not equal to 0, the domain of fx is negative infinity, comma positive infinity. You remember that? We talked about that long time ago, maybe a couple of weeks back, maybe. Right? So this is a linear function, right, with coefficient of x is not equal to 0. So that's why the domain of this function is set of all real numbers, which is negative infinity, comma positive infinity. And that means like this function is good, this function is well defined for any values of x. It is good for every values of x, right? You see what I'm talking, right? You come up with any values of x, plug in there, then your function is defined. There are no such values of x for which the function is undefined. That makes sense? Okay. So the domain of this is this. And now how do you find the domain of this function, guys? Do you have any idea? What will be the domain of this function? And this is a radical function. You see that? A square root function. Square root. Do you see that? Radical 2x minus 1. So what do you think? So this function is well defined if this radicand, so that means the value under the radical sign is greater or equal to 0. Is that right? If this is negative, if 2x minus 1 is negative, so you'll have a square root of negative, which is not a real number. That makes sense? So now this function is well defined if you have 2x minus 1 is greater than or equal to 0. Right? So now if 2x minus 1 is greater than or equal to 0, so this is 2x is greater than or equal to 1, you divide both sides by 2. So you cross them out. So that will give you x is greater than or equal to 1 over 2. Make sense? Are you with me? Yeah. So now what is the domain? So this means this function is well defined. This function is good for any values of x greater than or equal to 1/2. So the domain, what will be the domain now in an interval notation? So it's going to be 1/2 comma positive infinity. Make sense? So it's going to be 1/2 comma positive infinity. So now remember the domain of f plus g, domain of f minus g, and domain of fz includes all real numbers in the intersection of the domain of f and domain of z. So what is the domain of f? Negative infinity comma positive infinity. What is the domain of z? Bracket 1/2 comma positive infinity. Is that right? So what is the intersection of this and this? What is the intersection of this and this? So what is the common? You know the intersection means, right? Intersection, the overlapping set of these two. You know what I mean? So what's that? Did you get it? So look here. So negative infinity comma positive infinity, this set. This is negative infinity comma positive infinity. You know that, right? And then 1/2 comma positive infinity, 1/2 comma positive infinity. So you have 1/2 here, and this is positive infinity. So this is 1/2 comma positive infinity. This. Right? This. Are you with me? Right? So what is the overlapping part of bracket 1/2 comma positive? What is the intersection of this and this? 1/2 comma. Yeah, this is the overlapping part, right? This is the overlapping part. You guys know that? This is overlapping. Is that right? right? This. And make this also. So now the intersection is intersection of negative infinity comma positive infinity and half comma positive infinity is, are you with me? You know the intersection means, right? The common. So what will be the domain of f plus g? Domain of f plus gx is going to be is going to be this. The domain of f minus gx is also the same thing, right? Right? The domain of fz is also the same, you know. So this is half comma positive infinity. Are you with me? And the domain of f over z, right, is also the what? Also includes the set of all real numbers in the intersection for which gx is not equal to 0. Right? Remember that? Look here. Read that. While the domain of f over z includes those real numbers in the intersection of the domain of f and g for which gx is not equal to 0. Did you see that? So, what is the intersection of the domain of f and g? 1/2 comma positive infinity. Is that right? Right? But you have to exclude those values of x that makes gx 0. Because gx cannot be what? 0. Are you with me? So now what is your gx? Your gx is radical. Your gx is radical. Look here, your gx is radical 2x minus 1. Right? So now what value of x makes gx 0? So to find that, are you with me, guys? Huh? Look at here, okay? The domain of f over z includes those real numbers in the intersection of the domains of f and z for which gx is not equal to 0. So you have to find the value of gx. So you have to find the value of x that makes gx equal to 0. Is that right? And then you have to exclude that values of x.
0.5, wasn't it?
Exactly, yeah. 0.5, yeah. Which is 1/2, right? Yeah. So you just need to find, hey, what makes the value of gx 0? You solve it. Set gx equal to 0, and you do 2x, this gx is radical 2x minus 1. Is that right? This equal to 0. And so you square on both sides. Are you with me? So it's squaring. So that will give you what? 2x minus 1 equal to 0. And that will give you 2x equal to 1. So that will give you x equal to what? 1 over 2. Right? So now from the domain this, from the intersection this, from the intersection of the domain of f and z, which is 1/2 comma. So this is 1/2 comma positive infinity, right? You have this, right? From here, you have to exclude 1/2. That makes sense, right? So now from here, you see that? So this is the intersection, right? So from here you have to exclude 1/2. So that means the domain of domain of f over z x is, so you exclude from the intersection, you have to exclude 1/2, okay? So that will be what? Simply, you know this will be parenthesis here, right? So this will be parenthesis 1/2 comma positive infinity. Make sense? Because you have to exclude 1/2. Yep. Yep. Okay. So, if possible, use the given representation of function f and g to evaluate f plus z4, f minus z negative 2, f g1, and f over z 0. So how do you find out that? So look at the graph, okay? So if you look at the slides, you see the graph, right? So look here, you need to find out f plus z of 4. So f plus z4. So that is going to be, by definition, this is same as f4 plus g4. Is that right? So now look at the slides, okay? If you look at the slides, look here. So if you look at the slides, what is the value of f4? What is the value of f4? So f is blue one, okay? The function f is the what? The graph of function f is the straight line. This is the blue straight line. And the graph of gx is the what? Red one. Is that right? So now what is f of 4? F of 4 is? What is f of 4? What is the value of y when x equal to 4? Are you with me? You know the f4 means, right? f4 means the value of f when x equal to, the value of y when x equal to 4. That makes sense? So when x equal to 4, what is your f of 4? It's going to be 9. Are you guys with me? So look here, you have a graph like this, guys. Look here. And this is 4. So this is your y equal to f of x. If you want to find f4, you see, this is 9. So this is f4 is what? 9. That makes sense? And plus, so you need to find the g4, right? Your g is like this. Your g is, hold on a second. I want to use the red one, okay. So your g is like this. Is that right? So what is your g4? Your g4 is like this. So this is I think like if you look at the graph, that's going to be g4 is going to be what? 2. Right? Right? So now the 9 plus 2, what will be that is? So this figure is not to scale, okay? You know what I mean? Like I just, so this is 9 plus 2 equal to what? 11. Make sense, guys? So now the next one is, let's say if you want to find f over g of 0 by definition, so this is same as f0 over what? g0. Right? And now if you look at the graph, so you have a graph like this, okay? So this is your y equal to fx. And this is your y equal to gx. And this is origin, okay? This is origin. This is origin. So this is x-axis, this is y-axis. Is that right? Right? So what is f0? What is the value of y, right, when x equal to 0? Look at the graph. 0. So f0 is 0. So now this black one is, you see, this is the graph of the function y equal to gx. So what is the value of g0? So g0 means what is the value of y when x equal to 0, right? For g function. That makes sense? For g function, what is the value of y when x equal to 0? What is that? What is g0? 0. So now you see this is going to be 0 over 0. Is that right? And this is what? What is 0 over 0? Undefined. Does that make sense? So this is undefined. You can do that, Okay. Yeah, f over g of 0 is undefined. Now look at the table. So if you look at the table, you need to find out f plus g4, right? So which is f4 plus g4. Are you with me, guys? You look at the slides, okay? So if you look at the slides, so let me. So you look here. Okay, this is your x, this is your fx, and this is your gx, okay? So this is -2, -3, and this is what? Undefined, 0, 1, 0, and this is 1, 3, 1. So this is 4, 9, 2. Are you with me? Yeah? Now the question is, you look at the table and figure out the value of f plus g4. Then f plus g4 is same as f4 plus g4. So what is the value of f4? No, what is the value of fx when x equal to 4? Look at the table. 9. So f4 is 9. Are you guys with me? So what is the value of g4? So what is the value of gx when x equal to 4? 2. So 9 plus 2 is equal to what? 11. That makes sense? So now if you want to find out f minus g of -2, this is same as f of -2 minus g of -2. Right? So what is f of -2? What is the value of f when x is -2? -3. So this is -3 minus, what is the value of z when x is -2? Undefined. So you see -3 minus what? Undefined. What will be this? This is undefined. Is that right? Right? So now let's do the last one. Okay, so you have f over z of 0 by definition. So this is same as what? f0 over g0. Right? What is f0? What is the value of f when x equal to 0? What is f0? 1. And over, so what is the value of z when x equal to 0? 0. So what is 1 over 0? This is undefined. Are you guys with me? Okay, so we did this one, right? You see that? Yeah. Okay. So now the next one is the difference quotient, okay? So the next one is the difference quotient. So the difference quotient is defined as this, okay, f of x plus h minus f of x over h. So this is the difference quotient. And this is similar to the average rate of change. So if you have a, let's say, you have a function like this. So this is the graph of the function, okay? And you have x here, and the neighboring points, the point pretty close to this, let's say this is x plus h. So this is the function y equal to fx, okay? And this point is going to be x comma fx. Because x value is x, y value is f of x. And this point here is going to be x plus h, comma f of x plus h. See that? Right? And if you find the average rate of change, what do? F of x plus h, this is y2 minus y1. F of x plus h minus f of x over x2 minus x1. X plus h minus x. Are you with me? So what I'm saying is, if you want to find out if you want to find out average rate of change, you simply do, so you consider this point as the x1, y1, this point as the x1, y1, and this point as what? x2, y2. x2, y2. So now you simply do y2 minus y1, which is f of x plus h minus f of x over x2 is x plus h minus, right, your x1 is x. And now you see that? So this is same as f of x plus h minus f of x over this x and x cancel, you have this. So this is the what? Difference quotient. Make sense? Yes? Okay, so how do you find out the difference quotient for the function fx equal to 2x squared minus 3x? Okay? So what is your fx? What is your fx? 2x squared minus 3x. Okay? So to find the difference quotient, what do you need to find? You need to find the value of f of x plus h. Right? What do you need? You need the value of f of x plus h. You already have fx. What is fx? 2x squared minus 3x. So now tell me, how do you find f of x plus h? How do you find this? So how do you find f of x plus h? Hey, what is your f of x? What is your f of x? How do you find f of x plus h? You plug in what? You plug in x plus h for x. That makes sense? Are you with me? Are you with me, guys? Let's see, if you have fx equal to 2x squared minus 3x, so how do you evaluate f of a? How do you find f of a? You plug in a for x. Is that right? So this is 2 times a square, because you plug in this 2a squared minus what? 3a. Are you with me? If you want to find out f of 1, how do you find this? You plug in 1 for x. So 2 times 1 is square minus 3 times 1. Similarly, if you want to find out f of x plus h, what do you need to do? You need to plug in x plus h for x. Is that right? So this is 2. Here it will be x plus h square minus 3 times what? X plus h. That makes sense? So now, hey, how do you simplify this? This is same as x plus h times x plus h minus 3 times x plus h. Make sense, guys? Right? X plus h square is x plus h times x plus h. Good? So now, what do you do, guys? Let's simplify this x plus h times x plus h. This is a side work, okay? Are you with me? X plus h times x plus h. So what will be this? X times x, you just use the FOIL. X times x, x squared plus x times h is xh, right? Plus h times x is xh plus h times h is what? H squared. You got it? So now it will be x squared plus 2xh plus what? H squared. Okay? So now this will be 2 times x squared plus 2xh plus h squared minus 3 parentheses x plus h. So you distribute this 2. This is 2x squared plus, this is 2 times 2, 4xh plus 2 times h squared. This is 2h squared, right? And then you distribute this negative 3. Negative 3 times x is negative 3x. Negative 3 times positive h is negative 3h. Did I make sense? Is that good so far? So now, if you want to find the difference quotient, right? Are you with me? So look here. So now I just computed, I just found the value of f of x plus h. This, right? So I will plug in this value for f of x plus h. Can I do that? Yes? For now, are you guys with me? In place of f of x plus h, I can write down this, right? So it's going to be this f of x plus h is 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus this minus here. And then what is my f of x? What is my f of x?
2x squared minus 3x.
Yes, 2x squared minus 3x over what? H, this h. Are you with me? This f of x plus h is hold this thing up to here and this minus from here, and the fx is given this 2x squared minus 3x. Okay, so now this is same as 2x squared plus 4xh plus 2h squared minus 3x minus 3h. You distribute this negative, okay? This is negative 2x squared, and negative times negative is positive 3x, right? And this whole over h. You got it? So now this positive 3x and this negative 3x, I can cross them out, right? And then Is there any other thing? Yeah, positive 2x square. Did you see that? This positive 2x square and negative 2x square. This and this. I can cancel them. Right? So now it's going to be, so what will be here? Do you have a 4xh plus 2h square, right? Minus 3h over h. Now you have the common denominator h. Either you can factor out h from the numerator. There is two ways. Okay, you can factor out h from the numerator. You see, you have a h here, and h here. You can factor out, right? So what will be here? This is 4x plus, right guys? This is 4x plus 2h minus 3 over h. This h, that is cancel. So now you'll have a 4x plus 2h minus 3. Or you can separate, you know what I mean? So you can do like a 4xh over h plus 2h square over h minus 3h over what? 3h over h. So this h is cancelled, this h is cancelled, and this is square and this cancel, right? So it will be 4x plus 2h minus 3. Either way will be fine. That makes sense? Okay, so now this is called the what? Difference quotient. Yeah. Did you get it? Good. Okay, so now the composition of functions and domain, okay? So composition of functions. So if you have two functions f and g, so let's say you have a function fx and gx are given. If you want to find out the composition of f and g, okay, the composition of f and g is defined as f o gx is same as what? F of gx. Or if you have this, so this is same as what? This. This is defined like this. So this is the notation. You see the little o here, or you can say f circle g or f o g, whatever, right? This is the notation, okay? So this is defined as f parenthesis gx. And if you have a g o fx, is same as g parenthesis fx. You see that, right? Okay. Now, look here, guys. If you have fx equal to 2x minus 1 and gx equal to 4 over x minus 1. So let's say your fx is 2x minus 1 and your this. So you want to find out f o z of 2. Okay? Make sense? So now how do you define composition? If you have a f of gx, it will be what? F parenthesis gx. Right? Look here, the definition. If you have a f o gx, so it will be f parenthesis gx. So now if you have a f o g2, it will be f parenthesis g2. This is from the definition. Make sense? Right? So now this is same idea. What is g2? You plug into here, okay? If you want to find out g2, so what is your g2? What is your gx? 4 over x minus 1, right? So what will be your g2? So your g2 is 4 over 2 minus 1. So 4 over 2 minus 1. Are you guys with me? So this is 4 over 1, which is what? 4. So g2 is 4. Right? So now your g2 is 4, okay? So now this is f of 4. So how do you find out f of 4? So what is f of 4?
Read into 2x minus 1.
Yes, you plug in 4 in what? 2x minus 1, right? So what will be that?
7.
2 times 4 is 8. 8 minus 1, what? 7. Yes. Did you get it? Yeah. So now if you want to find if you want to find G circle F of 3, so by definition, what will be here? So this is same as Z of F3. This is by definition. Is that right? So now, are you with me, guys? So now this is going to be G. What is F3? What is F3?
5.
Yes, you plug in 3 here, okay? So 2 times 3, 6. 6 minus 1, 5. So now you need to find what? G5. So what is G5? What is G5? Yeah. So G5 is, you plug in 5, right? So this is 4 over 5 minus 1, which is what? 4 over 5 minus 1 is 4. This is what? 1. You got it? Hey, did you get it? Okay, guys. What? Did I make a... hold on a second. So, yeah. So G... okay. I did G of F of positive 3. That's okay. So now, you got it, right? So now look here, right? If the function fx equal to radical x and gx equal to 4x plus 2, you need to find out f o g x and its domain. Okay. So you have a fx equal to radical x and gx equals to 4x plus 2. So you need to find out f o g x. So that is f parenthesis gx by definition, because f o g x is f parenthesis gx. Right? So this is f. What is gx? What is gx? 4x plus 2, right? So you can plug in 4x plus 2 for gx, because gx is what? 4x plus 2. That makes sense? So now look here, how fx is defined. Fx is radical x, right? Right? So fx is radical x, but what do you have here? F of 4x plus 2. So what will be here? Yes. Exactly. So your fx is radical x. So if you want to evaluate f of 4x plus 2, you replace this x by what? 4x plus 2. Makes sense. Did you get it? So this is radical 4x plus 2. Okay? Good. So now, if you want to find, right, so, oh, okay. Now we need to find the domain. So how do you find the domain of f of gx? So now, look here, guys. So the domain of fx, look here. This is your fx, this is your f of gx, right? So now, if you want to find out the domain of this function, so you see this 4x plus 2 must be what? Greater than or equal to 0. Because this is a square root, right? So this value under the radical sign, this 4x plus 2 must be greater than or equal to 0. Is that right? If you want to find the domain. So now, are you with me? So how do you solve this inequality? Huh? How do you solve this inequality? Are you with me? I am going to find out the domain of this function, okay? So domain of this function is this 4x plus 2 must be greater than or equal to 0. Subtract 2 from both sides. Is that right? So if you subtract 2 from both sides, you cross them out. So the 4x is what? Greater than or equal to negative 2. Divide by 4. What is that? Is x is greater than or equal to what? Negative 1/2? Is that right? So now you have a x is greater than or equal to negative 1/2, right? So I think you got this x is greater than or equal to negative 1/2. So if you want to find the domain of f plus z, so that will be what? So the domain of f plus g, right? So let me write down here. So the domain of f plus g, not f plus g, f of g, I'm sorry. F of g is, you see this is a number line. So you have a negative 1/2 somewhere here. So the x is greater or equal to negative 1/2. So that means you have this part. See that? So this is the domain. This is the domain. So you can write in an interval notation like negative 1/2 comma positive infinity. Make sense? Okay? Did you get it, guys? So now you need to find out the GOFX, okay? So GOFX. So by definition, this GOFX is same as G of what? Fx. Right? So this is G of Fx. And then how do you this? What is your Fx? Radical x. Is that right? Are you with me? So this is from the definition. Look here, GOFX is G parenthesis Fx. This is from the definition. But you see, what is your Fx? Your Fx is radical x. Right? Are you with me? So now, can you let me know what will be g of radical x? What will be this? Remember, gx is defined. Gx is defined like gx equal to 4x plus 2. It is defined like this, right? Right? So what is z of radical x?
4x plus.
Now look here, just think like this. You have gx equal to 4x plus 2, okay? So how do you find g of a or g of b, whatever? Like, how do you find g of b? Just forget about this. Look here, okay?
Substitute the x for b.
Exactly. So that means 4b plus 2. Is that right? How you find g of y?
Substitute y, so it'd be 4y.
Exactly, 4y plus 2. You substitute y for x, right? So now my question is, hey, how do you find g of radical x? You substitute,
X for radical x.
yes, you substitute radical x for x.
Okay.
Is that right? You see what I'm talking, right? If you want to find gb, you substitute b for x. If you want to find gy, you substitute y for x. If you want to find g radical x, you substitute radical x for x. So this is for radical x plus 2. Make sense? Okay, guys. So now what will be the domain? Can you let me know what will be the domain? What would be the domain of g o f x? You know the domain of f is all real number greater than or equal to 0, right? And now this is 4 radical x plus 2. So this function g o f is well defined for any value of x greater than or equal to 0. Right? Is that right? So now what will be the domain? The domain of this is going to be 0, positive infinity. So you include 0, okay? So look here, this is not good for what? Any value of x less than 0, right? Because you'll have a radical of negative number. Are you guys with me? Yeah. Good. So now let's do this, okay? Any questions so far? So look here. So what is your f of x? 6 over x minus 3. And what is your g of x? 1 over x. So now how do you find f o g x? How do you find this? Look at the definition. So what is the definition? What is this? F of gx is same as what? F of gx. Is that right? So this is this. Make sense? So now this is same as f, but what is gx?
1 over x.
1 over x. Right? Right? So what is f of 1 over x? So what is f of 1 over x? How do you evaluate f of 1 over x? So what is f of x? 6 over x minus 3, right? So what will be f of 1 over x? You plug in 1 over x for x, right? Or replace this x by what? 1 over x. Does that make sense? Yes? So it's going to be 6 over 1 over x minus 3. Now, hey, let's evaluate the denominator, okay? So let's do a side work. Let's do here. Your denominator is 1 over x minus 3. Right? So this 3 has a denominator 1. Is that right? Now I'm going to simplify this. So what is your LCD? Your least common denominator is x. Right? So I want to make x on the denominator. So you already have x, so you multiply this by x and multiply this by x. Did that make sense? So now this is same as 1 over x minus 3x over x. Right? So now this is same as 1 minus 3x over x. That makes sense, guys? So this is 6 over this 1 over x minus 3 is what? 1 minus 3x over x. 1 minus 3x over x. So let's simplify this, okay? So this is same as what? This is same as 6 divided by 1 minus 3x over x. Is that right? Now, you see it has 6 as the denominator 1. So now this is 6 over 1, and this division sign will go into multiplication, and this is x over 1 minus 3x. Because when you switch division into multiplication, you switch numerator and denominator of the what? Second fraction. Is that right? You know that, right? So what is that is? So that is 6x over 6 times x, 6x over what? 1 minus 3x. Does that make sense, guys? So now f of x is equal to 6x over 1 minus 3x. Okay? Make sense? So now, how do you find the domain of this function? How do you find the domain of this function? So what values of x makes the denominator 0? Because you see, if the denominator is 0, this function will be undefined. Is that right? Are you with me? This is a rational function. Look at the denominator. So denominator cannot be 0, right? So what is the denominator here? 1 minus? What is the denominator?
1 minus 3x.
What values of x makes the denominator 0? Yeah. What? To find the value of x that makes the denominator 0, you say it 1 minus 3x equal to 0. So negative 3x equal to negative 1. You divide both sides by negative 3. Is that right? You divide both sides by -3. So you cross them out. So x equal to what? 1/3. That makes sense? Now, 1/3 makes the denominator 0. Is that right? So that means makes the function undefined. Right? So you have to exclude 1/3 from the domain. Are you guys with me? So you have to exclude 1/3 from the domain. So somewhere here 1/3 you have to exclude. Okay, you make a hole here. Are you guys with me? Now, you got to be a little bit careful here. So you see this f of gx is defined as what? F of gx, is that right? If gx is undefined, then f of gx will also be what? Undefined. Are you with me? You see what I'm talking, right? Now, f of gx is defined as what? F of gx, right? If this gx undefined, what will happen? If gx is undefined, this is undefined, okay? Gx is undefined, so it will be f of undefined. F of undefined is what? Undefined, is that right? So now what value of x makes gx undefined? What is your gx? Your gx is 1/x, right? What value of x makes gx undefined? No, if x is 0, it will be 1/0, is that right?
Yeah.
Yes? Yeah. So x equal to 0, the value of x equal to 0 makes this function undefined, is that right? So now you have to exclude that 0 from here also. You know, so let's say the 0 is somewhere here. You have to exclude that 0 also. Are you with me? So now what will be the domain, guys? You see what I'm talking, right? So now the domain is going to be what? So you see that? So the domain is going to be -infinity all the way up to 0. Is that right? Because you make a, are you guys with me? Because you see this -infinity all the way to 0, union 0 all the way up to 1/3, right? Union 1/3 all the way up to what? Positive infinity. That makes sense? You cannot include 0 and what? 1/3. That makes sense? Okay, good. So now you see that, right? So the next one is the part B is you need to find G circle fx, right? And by definition, look at the definition. What is G circle fx? G fx. G parenthesis fx. Is that right? So this is Z. What is your fx? 6/x minus 3. Does that make sense? So now, what is this? Look at gx. Gx is 1/x, right? What is g of 6/x minus 3? 1/, you plug in, you replace this x by what? 6/x minus 3. Does that make sense? So now this is same as what? 1 divided by 6/x minus 3. Is that right? Right? And you switch, it's going to give you what? 1 multiplied by x minus 3/6, right? Which is what? X minus 3/6. Did you see that? Okay, I want to stop here, guys. I will see you next time, okay? Bye.